All right, so I'm going to talk a little bit about some fasteners on the table here. So a really common one, bolts have threads and they have nuts. So you have a bolt that's threaded on the outside of the shank there, and then you have the nut that's threaded on the inside, and they can turn, and then that locks together. You can tighten it down, so it clamps something together. So you can think about bolts as clamping things together that you can undo too. Now, you can get more surface area in the clamping by using washers. You'd slide that on, put the material through the holes in the material, and you'd have to drill the holes in the material, and then put the nut on, or put another washer on and put the nut on and tighten it down. You might even use, in that combination, a split washer. That would help. It creates tension and helps it keep it from loosening up. So if you had something that you're building that was going to vibrate a lot and you're worried about it coming apart, you might use a split washer to help, or a locking washer. There's also what's called fender washers. So you can see they're a little wider. So same size inner hole, but much wider over here, the fender washer. So you get more surface area clamping. So the bolts that I just held up there were 1/4 That's the diameter of the bolt is 1/4 inch, and then the number of threads per inch is 20. There's also metric sizes, so just to get you confused. And they come in all different, you got smaller ones. So when if you're buying hardware, you really have to pay attention to that, because there's also 1/4 editing. 1/4 is national coarse, so sometimes you'll see NC, and if you have a 1/4 that's national fine, you see an NF. A lot of times it won't really matter what you're doing. It's more common to see the 1/4, but if you buy a 1/4 bolt and 1/4 nuts, they won't really go together. They'll kind of fit like they go together, and then you'll jam it on, and it'll strip out threads and be a mess. This is a hex head. So for a hex head, you could use a wrench. And for a 1/4 it's usually, not all the time, but most of the time, 7/16 is the size. So I can turn it. You can flip it to get into tighter areas if you run into stuff. And this is an open-ended part, and this is the closed end part that fits over there. There's also what sometimes, is an adjustable crescent wrench, or a friend would call it, give me the universal. And that, you can adjust that jaw. So when you do that, I'm going to do this backwards. If I'm tightening it, if I'm turning that, I want to have this being into the turn. What I don't want to do is, one thing I don't want to do, many things. One thing, if I do it like this, this tends to loosen up. And also, so if you have it a little loose and it's not the right size, what can happen is you start rounding over those corners of the hex, and it strips it out. So if you have the wrong size wrench, or if this is coming loose, so when you use that, you want to make sure that you have it tight and adjustable, and that it's going this way, because if you go the other way, a lot of times this will start to loosen up. Which, in saying that also means regular kind of pliers and vice grips and stuff like that, well, they can work in a pinch. Not a good idea to tighten hex head bolts up with a vice grips or pliers like that, because you can start to strip out the thing, especially on equipment. Pieces of equipment that you might have, try to use the right size wrench. One more device that you can use to drive a hex-headed bolt or nut is a socket wrench. So it has kind of like the same thing here. They're at 7/16 is this closed end, and they make these deeper and such, but that fits in there. And then when I turn this, it's got a ratchet thing, so it slides back this way. You can hear it clicking, and then when I push forward, it pushes. Now I can loosen, if I turn this top piece, I can loosen like that, and then it ratchets the other way, and I can turn it and loosen it that way. All right? And usually it's nice to have these in combination, so you have this on the one side and this on the other for the right thing. Then also you have kind of a slotted head, which you would use a flat-headed screwdriver for. And you don't see as many of these. I'm just turning it into my fingers for no reason. You don't necessarily see these used as much, but they do have an aesthetic to them. So if you're depending on what you're doing, they can be a nice look. There's also the other type of nut you might come across as a wing nut. It's not meant to use a wrench on, it's just meant to tighten with your fingers, although sometimes I will use pliers to tighten those. That's for something where you would want to be able to take it apart, without a tool. So you could tighten it down, twist it down, and then loosen it if you needed to. So those are bolts. And again, a variety of sizes and diameters. Then the next thing I'm going to show you is a sheet metal screw. This is a simple one with a pan head and a Phillips. And by the way, Phillips, the cross, turns there. And this just cuts in. You have to drill the right size hole. This is only good for thin sheet metal. Screws for sheet metal are that. They're for thin sheet metal. Thicker stuff would be harder to get it to cut through. So you'd want to drill a hole that the bolt would slide through. So the hole you drill for a bolt will be the size, that 1/4 inch, or even a little bit larger if you want a little play. Some they do design if they have a sharp little point for very thin, soft metals, just to kind of puncture through. And some have a little drill bit head on them. So it's like a built-in drill bit, drills the hole, then this threads in. All right, so we're going to drive the screw we're going to use has a Phillips head to it, and it has one of those self-drilling drill bits on the end. Well, you got to drill it. It's got a drill bit on the end of it. And we're going to use our drill, hand drill, and it has a keyed chuck. Remember, it has the jaws. Come up, and I'm going to put a driver bit. This is a Phillips driver bit. It would generally not work to hand screw in a self-drilling thing. You would have to drill a hole first. But anyway, so I'm using that, and I'm going to take, just a reminder, the pin meshes up with the, we tighten it down. Again, the trigger, when I pull this trigger, the more I pull it, the faster it goes. I'm going to have a little bit of control over it. I'm going to not just floor it into it because I'll lose control and it'll throw the bit. Hopefully not into the screen. And then remember, you have forward and reverse, and we want it in forward for driving the screw. And I've got 2 pieces of metal, and I could, or I will, make a little center punch. So I have at school we have some center punches. I have some somewhere, but the first one I grabbed was a homemade one made out of an old file, a rat tail file. But anyway, it's hardened steel. I just want to make a little divot where I want that hole to be, where I want the screw to go. That'll keep the drill bit from just traveling around. I'm going to use a ball peen hammer. Generally speaking, even though I'm not using the ball peen part, just aesthetically, if you grab a claw hammer for like pounding nails and pulling nails, I cringe a little bit because it seems more appropriate to use a ball peen hammer. Anyway, so I'm not going to go crazy. I'm just going to get a little divot there. Kind of hard to, probably impossible to see in the video. But anyway, so I got that. That'll help keep the screw on board. And then I could clamp these in a number of different ways, but for just this little demo, I'm going to overlap those. And I'm going to utilize this situation right here with the vise. Because you don't want to try to hold on to these things and drill into it, especially this small. If you have big pieces, you might be able to stand on them or something like that, but if these started spinning in the drill, if it caught and these are spinning and I'm holding on to it, that metal will cut up my hands pretty badly. All right, so I put the Phillips into there. All right. Let's see. So I don't want to pull the trigger too hard. I want to get it going. It's a little wobbly. Put my foot on my vise stand. So I'm applying some pressure, but again, not too much. Pick up the speed a little bit. We haven't gotten, let's see if you can see, there's a little bit of grinding. I can see that I'm digging in and it's drilling in. So I eased off. As soon as I saw that it went through, I eased off a little bit. Now I'm going to tap on it a little bit and get it to lock up. Like I said, sometimes I'm doing that and I'm just, and I bang, and I just keep going and I snap the head because the screws are, you know, harder to cut through the metal, which makes them more brittle, which can make them kind of fragile. So anyway, you grind that back part off, or have it on the inside, or have it showing. Maybe you want a very aggressive looking sculpture. All right? So that's just using a sheet metal screw to hold some metal together.